Okay, let's take a look at some review problems for exam 3. The first example, we want to find we have the following probability distribution of a discrete random variable, and we eventually want to find the mean and standard deviation of this discrete probability distribution. So the first thing you want to do is create a column called the x times p of x column. And so you just write down x and p of x, and then you multiply x times p of x, x times p of x, and then you add that up, and that's going to be the mean. The standard deviation, we're going to have to create a third column called the x squared times p of x. And so what we do here is we square x, and then we multiply by p of x. So 0 squared is 0, 1 times 0.35, and 4 times 0.47. We're going to use this number here in just a second. Okay, what's the probability that if you perform the underlying procedure associated to x, the outcome would be assigned a non-zero number? Well, non-zero is anything other than 0. It's kind of like saying non-chocolate. Non-chocolate is anything other than chocolate. So non-zero just means we're going to take 1 and 2. So what's the probability of 1 plus the probability of 2? So non-zero is x greater than 0. It means non-zero. It's equal to probability of 1 plus 2, which is these two. Add these together. Okay? Now part B says make a histogram. So here we just label x and p of x, and then draw the height of the probabilities along the x-axis here. It's fairly straightforward. Okay, here's where we calculate the mean and standard deviation. So the mean is add up the products of x times p of x. So that's that column up top, x times p of x. Add those up, 1.29. Standard deviation is the square root of the sum of x squared times p of x minus the mean squared. The mean is right here. We just got the mean. So add that up, minus 1.29 squared, and we get 0.75. Okay. Now here we have an insurance company that sells a $100,000 one-year term life insurance policy to a female in the 40 to 55-year-old age bracket that has no prior history of serious health-related problems. The annual premium is $150. Suppose that a reputable statistics report from the previous year shows the percentage of females in this age bracket that survived is 99873. Find the expected value of this policy. Well, there's really only a couple of things that can happen here. She either survives or she does not survive. And if she survives, then the profit is just 150. If she does not survive, then the profit, there's no profit, it's negative. It's 150 minus 100,000, which is minus 99,850. And so to get the expected value, we just multiply the profit of 150 times the probability she lives, which is this, and the probability which she does not live is this. This is the complement. It's 1 minus 0.99873. Gives you 00127. Okay? And then to get the expected value, we just add these values up, and we get the mean is $23. So the insurance company can expect to earn $23 on average per similar policy. Okay, now we'll do a couple binomial. Suppose you flipped a fair coin 6 times. What's the probability of getting heads on exactly 4 of those 6 flips? So this follows binomial distribution. The probability, so n is 6. The number of times is that you toss is n. The probability of success is 1/2 because probability of heads is 1/2. And so now we can just look this up using table 3, and that's what I did. I went to n equals 6, I looked at p equals 1/2, and I looked x equals 4, and it gave me this number here. Now here we have a multiple choice test, 5 multiple choice questions. 4 possible choices presented for each question, only 1 is correct. So this is a binomial where we have the number of trials is 5 because there's 5 questions. Probability of success is 1/4 because 1 out of 4 is correct. And we want to know what's the probability to get at least 3 of the 5 correct if we guess. Well, that's going to be the probability you get exactly 3 plus exactly 4 plus exactly 5. And you can look this up again in table 3. Now to calculate the mean is just n times p. So here we have binomial distribution that has 30 independent trials, where the probability of success on a given trial is 0.17. So here we have x follows binomial with 30. Okay, so n is 30 times 0.17, 5.1, and then np, 1 minus p, substitute in, standard deviation is 2.06. Okay, now we're moving on to 7, chapter 7. So we've got a normal random variable, represents the weights of adult males in pounds. The average population mean mu is 172. Standard deviation is 29. What's the proportion of males that weigh between 169 and 210? So this is x. The mean is 172. The boundary points 169, 210, 210, and this is non-standard normal distribution. And I will ask you to shade in and label all of this. Okay, so what we do, probability between 169 and 210 is x is greater than 169 but less than 210. Then we convert our boundary points, x minus the mean over sigma, x minus the mean over sigma. So z replaces x, and the mean is 0, and this is minus 0.1 and 1.33. So x becomes z. So x becomes z, and then we look up 1.31 and subtract that from 0.1. Area from here back minus the area from here back leaves what's in the center. Now this time we're talking about the distribution of x bar. So here, say if we take a random sample of size 50, what's the probability that the mean of the 50 is less than 160? So x bar follows a normal distribution with the mean equal to the population mean and the standard deviation equal to sigma over the square root of n. So n is 50. Population mean mu is 172. So we want to label the mean as 172, boundary point of 160, and then everything less than 160. So again, we have to convert x minus the mean over sigma. So x is 160, our boundary point, minus the mean, 172, over standard deviation, sigma over square root of n. And we get minus 2.93. So minus 2.93. This goes to 0. This becomes z. And then we look this up in table 5. Okay. Now here we want to find the 91st percentile. So this is x, and the 50th percentile is in the middle. That's 172. But the 90th percentile is going to be over here, such that 90% of the area is over here. So the question is, what is x? What is x? Well, we have to get the z-value that separates the bottom 90% from the upper 10%, and that's 1.34. Z is 1.34. So then we just plug everything in. We get approximately 211 words per minute. The z-value, by the way, this z-value is inverse norm of 0.9. Mean and standard deviation will be 0 and 1. Okay? This is 1.34. Okay, now we move on to the confidence intervals. So we have 200 high school students surveyed. 136 said they have been legally intoxicated at least once in their life. What's the point estimate? Well, the point estimate is based on the sample. So 130, so about 68% high school students have been intoxicated. And then here, we want to compute the confidence interval. So the confidence interval is based on this formula here. We have to know z alpha by 2, p hat, and n. So n is 200, p hat is 0.68. This comes from table 5. So table 5 here. Table 5. Just look that up. And then we get the margin of error. We take the point estimate and subtract the margin of error and the point estimate and add the margin of error. So we get a lower bound of 5951, 7649 is the upper bound. We say something like we're 99% confident the true proportion lies somewhere between here and here. Sample size question. State highway patrol officer wishes to estimate the number of legally intoxicated drivers on a certain road. How large should the sample be in order to be 99% confident the true proportion of drunk drivers on a certain road will not be different from the true proportion, or the estimate, will not be different from the true proportion by more than 2%. So no estimate available, no prior estimate, we use this formula. If we have a prior estimate, we use this formula. So z alpha by 2 comes from table 5 over the margin of error. We plug that in, always round up. Remember, always round up for the sample size questions. And then part 8, we're told that we do have a prior estimate. So we just plug the prior estimate in here, same values as before. And we get much more accurate sample size. Okay, now this time we want another confidence interval for the miles per gallon of a 2007 Ford Taurus. So we want the true value to be within the confidence interval with 95% confidence. So this is for the mean. Remember, this is confidence interval for the mean. Confidence interval for the mean. This points us to x bar, not p hat. So here's the formula, okay, the margin of error. And the margin of error needs t alpha by 2, s square root of n. So here, using the calculator, I calculated the sample mean, add them all up, divide by 13. Sample standard deviation, I just use the calculator again. You can use your summary statistics there on your calculator. And then the n is 13. Degrees of freedom is always sample size less 1. So 13 minus 1 is 12. And then this value, t alpha by 2, comes from inverse t on the calculator. And it's 0.05 because 95% confidence, then alpha is 0.05. Just subtract 1 and you get alpha. Divide by 2, comma, degrees of freedom is the next argument. It's 12. And then we calculate margin of error based on these statistics. Margin of error is this. We find our lower and upper bounds. Here we go, upper bound, x bar plus the margin of error. Then we have the meaning here. Okay, so now we have another sample size. We want to estimate the true value within 0.5 miles per gallon with 95% confidence. So we use the formula here. Sample standard deviation from the data set above is 3.21. Z alpha by 2 is from table 5, and then the margin of error is no more than 0.5 miles per gallon. 59. Okay. Now we look at the distribution of credit cards. So we want to know, suppose a sample of 500 adults is asked, do you own a credit card? Describe the sampling distribution of p hat. Well, the distribution of p hat is going to follow a normal because it's a random variable again with this mean here and the standard deviation here. So the mean is here and the standard deviation is here. So notice we just have to know p and n. P is 0.29. This guy here is p. And sample size is 500. So plug it in, we get the mean is this, standard deviation is this. What's the probability? Random sample of 500 adults, more than 30%. Answer, do not own a credit card. So that's p hat, more than 30%. The mean is 29 from above and 30.3, and then we shade in all this. So that's the proportion we want. So p hat is greater than 30. We have to convert, this is non-standard, normal. We convert it into a standard z-score using p hat minus the mean over sigma. So we get 0.49. and the mean becomes 0. And remember, we want the area to the right, so we have to reverse the inequality and change the sign of the number. And then look this up in table 5. Look up minus 0.49 in table 5. We get this area here to the right. This area. Oops. Let's see. The area is 3121. Take a look at the next question here. What's the probability that in a random sample of 500, between 25 and 30 do not own a credit card? So again, 0.29 is the mean, 0.25, and 0.3. So this is what we want. Okay, so again, we convert p hat into z using the z-score formulas. P hat minus the mean over sigma and p hat minus the mean over sigma. P hat and p hat. So we end up converting 0.25 p hat into z's, and we look these two. So remember, we want the area from here back minus the area from here back leaves what's in the center. So we look up these two from the chart, subtract the two, and we get the area in the center. Okay, what's the probability that of a sample of 500, 125 or fewer do not own a credit card? So x is less than 125 means p hat percentage is less than 125 over 500 or less than a quarter. So 0.29, 0.25, and this is what we want here. So again, same thing as before. We convert using the z-score formula, or convert our boundary point here, p hat minus the mean over sigma, and we convert p hat into z. The z-score is minus 1.97, and we look this up in table 5 and get the area to the left of the z-score, remember, is 0.0244. Okay, so hope this helps, and we'll see you guys next class period.